Okay, this is Algebra 2, Lesson 6.1, really foundational this chapter. I'm going to try to go fast, so don't be afraid to pause the video as you need to. I've got a lot of material to cover. This is really a foundational lesson as we take a look at quadratic functions. So we've looked last chapter at quadratic equations. Now let's look at quadratic functions. First off, we need to classify all kinds of functions and equations. All right, so the first thing here is the idea of how do we know whether it's linear, quadratic, polynomial, etc.? Okay, first off, that first column says degree. And this equation here that's listed, linear equation, is a first degree equation. How do you know that? Again, the exponent of the variable is the first power. It's a first degree equation. The fact that it is first degree equation generally, there's a few exceptions, but generally makes this linear. So why is it linear? It's linear because it is a first degree equation. Okay? Linear because it is a first degree equation. Now, how many variables are there? And you see all there is one variable. It's an x. That's it. So different variables. One, the fact that it's one variable makes it an equation. So the fact that it's first degree makes it linear. The fact that there is one variable makes it an equation, linear equation. What kind of solution do you get to a linear equation? You get a single point. You get a single point. And the graph of a linear equation looks like what? It looks like a single point on a number line. So the graph is a single point on a number line. Okay? All right, so the fact that it's first degree makes it linear, that there's only one variable makes it an equation. Second one, now we have a linear function. Well, again, understand what is the degree of this equation. It is a first degree. Again, if you look at the variable, that's first degree, that's first degree. Remember, the degree is the value of the highest degree term. So this is first degree, and that makes it linear. All right. The fact that it's first degree makes it linear. Now, if you look, how many different variables are there? There are two. There's an x, and there's also a y. So you got two different variables, and that gives us the aspect of the possibility of a function. And so generally, we'll classify them as functions, and then we'll look later on to make sure, indeed, they pass. Do you remember the vertical line test? Okay. But generally speaking, if it's got two different variables, we're going to consider it to be a function. What kind of solutions do you get? What kind of solutions do you get? Well, in this situation now, you have an infinite number of points. An infinite number of points. The graph of a linear function is you should know the answer to this, right? Linear, it's right in the word linear. The graph is a line. So this is a line in a Cartesian plane. A line in a Cartesian plane. Okay, so first degree makes it linear. Two different variables makes it a function. Functions are continuous sets of points for most part. Therefore, infinite set of points. It's a line in a Cartesian plane. Now we've got the term quadratic. Well, we talked about it last chapter. And we can see this is a second degree. So the fact that it is indeed second degree makes it quadratic. The fact that it's second degree makes it quadratic. And how many variables do we have? How many different variables? Just one. There are x's. Okay, I know we have an x squared and an x, but they're x's. There's one variable, the independent variable, the x. The fact that there is one variable, now we're back to an equation. All right, so when we solved quadratic equations last chapter, how many solutions did you get? You got two, right? And so the solution is 2 points. 2 points. And if you were to graph it, it would be 2 points on a number line. 2 points on a number line. So solution, 2 points, 2 points on a number line. Okay, so now we go down. What's the degree? Well, there it is right there, right? This is a second degree. How many different variables are there? 2. So the second degree makes it quadratic. The 2 different variables makes it a function. A function. All right, so what kind of solutions do you get? An infinite number of points. An infinite number of points. What's the graph? A parabola, Parabola. All right, Parabola. A parabola in a Cartesian plane. The whole chapter is going to talk about parabolas, and we'll look at them in a minute. A parabola in a Cartesian plane. All right, third then, everything else we're going to call polynomial. Notice the degree. This is a third degree. Could be fourth degree, fifth degree, sixth degree, seventh degree. So really, I should have written greater than or equal to third degree. Right? We'll just call polynomial. Hey, how many different variables are there? 1, and that's why this is a polynomial equation. What's the solutions? Greater than or equal to 3 points. Just depends on the situation. And this would be greater than or equal to 3 points on a number line. You see the pattern? I hope you do. Greater than or equal to 3 points on a number line. And then finally, polynomial function. So again, we're greater than or equal to third degree. This one happens to be what degree? And hopefully you're saying fifth, right? Because of that 5. All right, and then there are 2 different variables, an x and a y. Therefore, it is a function. What's the solution? Infinite number of points. And what is the graph? A polynomial in a Cartesian plane. I'm just going to say a poly in a Cartesian plane. And we'll talk about them toward the end of the chapter as well. Okay, so classification. Hey, this is an important chart. You should know this. I should be able to give you, if you look over to the left here, I should be able to give you something like this, and you should be able to say quadratic equation. I should be able to give you an example like this, and you should say polynomial equation. I should be able to give you something like this, and you'd say linear function. Okay? Basic knowledge that all Algebra 2 students should have. Okay. Let's take a look at down below here. The graph of a function of the graph of a quadratic function is a U shape, and that U shape is called a parabola. Always want to put an A after the B. Parabola. Parabola. All right, you see parabolas all over the place these days. Satellite dishes are in the shape of a parabola. Very, very unique. As I have more time, I'll talk more about the unique aspects of a parabola. I think it was neat that in hermeneutics class a couple weeks ago, Pastor Edwards was talking about a parable. Notice the word parable and parabola are so similar. And he was saying, I don't know what the math implications of this is, but the idea of a parable is that there is one main lesson of the parable. One main thing you're supposed to learn. If you look at a parable and try to learn 3 or 4 or 5 or 8 different things, you're way off. You're way off. A parabola has one central main thought. So let me just show you real quick. Afterwards, I said, hey, that fits math exactly. Don't do this on your paper, but here's the parabola shape, right? And a parabola has what's called a focus. Now, we talk about this more in advanced math, a focus. So let's suppose we had a satellite up here that's going to beam its communication all over the world. And of course, these waves are going to go every direction, right, out of this satellite. Well, the waves that come down and hit the dish, the parabola, no matter where they come in, they bounce to this single point, this focus, due to the shape of the parabola. As the waves come in, they bounce to that single point. I think it's pretty neat. the aspect of a parabola. But the U shape is the parabola. So let me get rid of all that and let's get rolling here. Again, I got lots to cover today, so I've got to be careful. All right, you don't know this yet, but looking at this, now I know that this is a quadratic function. It's a second degree, so I know it's quadratic, and it has two different variables, so I know it's a function. Therefore, I know the graph is going to be a parabola. The vertex is an important point, and it has coordinates of 3, -1. Now, we've learned this concept before, and I'll talk about it more and develop it more in the chapter. But the vertex is at 3, -1. So let me go on my graph. Go ahead and go 3 to the right, 1 down, plot your vertex. Okay, to show the shape of this function, I'm going to graph a few more points. Now, I'm already down here at 3. I'm going to go 2 points to the right. Excuse me. I'm going to go 2 to the right, and I'm going to use a 5 in my XY chart. So I'm going to take my function, 1/4 times, and where the x is, I'm going to substitute in that 5. Again, pause the video as you need to catch up. So, looking at this, 5 minus 3 is a 2. 2 squared is 4. 4 times 1/4 is 1. 1 minus 1 is 0. I have the point 50. And that's right there. Now, before I go any farther, look at the sentence below this graph. Parabolas are symmetrical. 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 Meaning they have an axis of symmetry. An axis of symmetry. Some call it a line of symmetry. I like that term better. Our book calls it an axis of symmetry. Okay, so for our parabola, the axis of symmetry always goes from the vertex. And so this one, just trust me, the axis of symmetry is right here. We're going to learn why it's there and all of those aspects soon. But here's the point. I know this. I'm going to teach you this. Because I have this point 2 spaces to the right of the line of symmetry, I know I have a point 2 spaces to the left of the line of symmetry. And I'm going to place that point right there. I don't even need to do the XY chart. I know it's there because I know the shape of a parabola is symmetrical. Okay, I need one more point. Let's use 7. So again, I'm going to go 1/4 times the quantity. In a moment, I'll sub in that 7 in red. Again, pause the video as you need to. So 7 minus 3 is a 4. 4 squared is a 16. 16 times 1/4 is a 4. 4 minus 1 is a 3. And I have the point 7,3. So 5, this point's at 5, right? So go 2 more to the right, 6, 7, and go up 3. 1, 2, 3. And right there. So 7, 3. Notice this is 4 away. So I know I have another point the other way, 4 away. All right. Oops, got rid of my point. 1, 2, 3, 4, right there. Okay, I'm going to take my blue. Now I'm going to connect this with a smooth curve, and you should see the U shape. Always easier to start at the vertex and go both directions. And there's my U shape. There is my line of symmetry, and it's a parabola. Now, by the way, how do you say the line of symmetry? Well, the line of symmetry would be x equal, and then the x coordinate of the vertex, which is a 3. Again, don't forget, coordinates of this vertex are 3, -1. And remember, the 3 represents the h, and the -1 represents the k. We'll deal with all this in detail down the road, okay? I'm just trying to get you to understand the shape and how it works and how we get it, okay? Parabolas. Parabolas. All right, let's go on. So we're going to start simple with the simplistic form of a quadratic, and that's y equals ax squared. All right, so think of the standard form of a quadratic. We use the quadratic equation with the aspect of ax squared plus bx plus c, right? Now this time we have y equals because it's a function, right? Not an equation. Instead of 0 where the y is, we have y. So it's a function. But notice what's missing. We don't have the bx. We don't have the c. So that's what goes in our blanks. There's no bx term and there's no c. So it's very simplistic. It's just this front part. Okay. Well, look, that implies that this is the most basic form of a quadratic function. And look, go back and look right here. Don't miss this part of it. Why is there no bx? Because get this, the value of b is 0, right? And in fact, you really have plus 0 times x. And what's the value of c? It's also 0. And that's why they're gone. Because the b value was a 0 and the c value is a 0, and we don't bother to write zeros. So it's stupid to say y equals ax squared plus 0x plus 0, although that's what we have. Okay? All right. Well, this is nice. For y equals ax squared, the coordinates of the vertex are always, 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 I always use red for my x's and green for my y's, 0, 0. Okay, awesome. The vertex is a key point of a parabola. And therefore, if there's no bx and no c, we always know that this parabola is at the origin. All right, so let me show you here. You guys don't have this in your notes. But, you know, there is a parabola of the form y equals ax squared. Okay, that's of the form y equals a. And notice where the vertex is. The vertex is at 0, 0. In addition, the axis of symmetry is always x equals 0. So go back and look on the top left. Here's the axis of symmetry. X equals 0. And notice the parabola is symmetrical. Mirror image left and right. Okay? Always. Always. Got to know that. It's important. Very, very easy. All right. What else? D. D. The sign of the A. The sign of the A. You say, Mr. Scarfi, what A? Okay, remember, we're at y equals ax squared, right? Y equals ax squared. The sign of the A determines if it opens up or down. Oh, wow. You mean these can go, if you look over here, you mean these can go like that as well? Yeah. Quite honestly, they can even point left and point right. That's advanced math. And they can even go on an angle. That's using trig functions in advanced math. But right now we're worried about either opening up or opening down. Okay, well look. Look at this one opening up. Notice how the function is heading toward what? It's heading toward infinity, and it's going up toward infinity. Now, is it heading toward positive infinity or negative infinity? Positive infinity. And math is orderly. So whenever you have a min, I'll talk about that in a moment, a min opens up toward positive y values, so the sign of A is positive. So if you have a positive A, it's a min, short term for minimum, and it opens up. So in our example, because the A value is positive, look right here. Here's our A value. It's a positive 2. It's a min, short for the word minimum, and it opens up. You might say, why is it called a minimum? The min is technically the vertex. And notice the minimum is the low point of the function, the minimum point of the function. That's why we call it a minimum. Okay, mins open up. What would be the domain of this? Remember, domain are all possible x values, right? What's the lowest possible x value? Well, though this is curving up, it's also curving out. And it has forever to curve out. So the domain goes to negative infinity. And what about on the right? Well, again, it's curving up and it's going up faster than it's going right, but it has forever to go right, and therefore it's positive infinity. So the domain is all the real numbers. Now remember, we can also write this as an interval. So we can write it parentheses, negative infinity, comma, infinity, and write it as an interval. All right? How about the range? Range. Well, if you look at the range, the y values, the lowest y value is what? 0. And the highest y value is what? Infinity. So can we say that? We can use set builder notation, set of all y's such that y is greater than or equal to 0. Or some will just say, hey, y is greater than or equal to 0. Or if we use an interval, and again, I love teaching you intervals because advanced math and calculus uses intervals. So bracket 0, comma, infinity, parentheses, right? The bracket means the 0 is included, greater than or equal to. And then the parentheses means there's no distinct n there. Okay, so it's a minute 0, 0. All right, so let me recap. What do we really talk about here with this example? The fact that the a value right here is positive, and a positive a value causes it to be what we call a min, which is a parabola that opens up. Technically, the min point is that minimum point of that function, right? And we label the domain and the range. So again, math is nice and orderly, so we're also then going to have a situation where we have a max, short for a maximum. Max is open down toward the negative y values, right? Look at this thing. Where's it heading? Toward the negative y values. So the sign of the a is negative. So again, here's our example. Look, here's a right here. It's a negative 2x squared. Because the a value is negative, it's a max and it opens down. It's a max and it opens down. Again, here's our max point. Isn't that the maximum or highest output point of the whole parabola? It is, and that's why we call it a max. And this opens down. Domain, again, is all the real numbers. If you were going to do interval, again, negative infinity, positive infinity. What is the range? Again, most will just say y less than or equal to 0. And again, if you want to say that in interval, remember, you always go lowest value first. So parentheses, negative infinity, comma, highest value 0, and 0 is included, so bracket. Okay? Pretty cool. Math's pretty awesome in the aspects. So max or min, the a value would tell you whether it's a max or it's a min. Very important information, highly testable, something everybody should know. All right, read the a value. If the a is positive, it is a min, it opens upward. If it's a negative, it's a max, it opens downward. Again, positive opens up toward positive infinity, heads toward positive infinity. Negative opens toward negative infinity. Okay, here's another aspect of a parabola. The relative width of a parabola is determined by the absolute value of a. Okay, a parabola can have the same width whether it opens up or it opens down. Okay, so this one has a positive a, this one has a negative a, but the absolute value of a controls how wide it is. Pretty neat. Okay, so we figure out the width by knowing some aspects of a. So we came up with a standard and we said basically this. If the absolute value of a is less than 1, then the parabola is considered to be relatively wide. Now again, you have to have something to compare it to. So what do you mean by wide? Well, anything that's less than 1 a value we're going to consider relatively wide. Now your book likes to say flatter. All right, you should always talk about wide and narrow, and now the book says flatter. All right, so flatter, relatively wide. So if you look up in the open space, If that's a parabola where the a is 1, if the a were half, it would be even wider. And if the a were an eighth, it would be even wider yet. And it's hard to draw. I'll show you more down below. Okay? Secondly, if the absolute value of a is greater than or equal to 1, then we will consider the parabola to be relatively narrow. Relatively narrow. Okay, and again, your book uses the term steeper. Steeper, and I'll show you that below. So relatively wide, relatively narrow. So let's take a look at some functions. Function number 1. Here's my a value. The absolute value of negative 5 is 5, so what is this thing? This thing is narrow. Again, your book's steeper, right? Second one, where's the a value? Right there. The absolute value of a half is half. A half is less than 1. This thing is wide, or your book, flatter. Right? So what's this third one? What's 3? And hopefully you say the absolute value of negative 0.7 is 0.7. 0.7 is less than 1. So again, this thing is relatively wide, or again, your book, flatter. Flatter. Okay. So here's an illustration of that. So we've got some parabolas, and let's use, we're going to match these parabolas up. I know you don't have all these colors, but the orange one here, and I'll use black, is the base model. Y equals 1x squared, usually that 1 wouldn't be there, is this orange parabola. Okay, that's the standard. That's the standard. And technically we would call that relatively narrow because the a value is greater than or equal to 1. So therefore the blue one has to be which function? Top or bottom? The blue is more narrow. So does it have to be top or bottom? It's got to be the top. You get more narrow as the a value increases. Consequently, the 1/4 has to be the wider one, has to be the y. Okay? And look, this is exactly the same for negative a values, right? If you look at these parabolas, they're exactly the same. One goes up and the other goes down because the a is positive in all 3 of the examples on the top, and the a is negative in all 3 of these examples on the bottom. So again, the orange one is the negative one. The -2 is the blue, steeper, and the flatter one is the -1/4. Okay, parabolas. Pretty amazing. Lots to learn and lots to deal with. All right, number 5, quadratic functions, the form y equals ax squared plus k. All right, to translate, we've talked about translation, moving the object to another place. To translate a function is to change its location. You change its location. You're not changing its shape, you're changing its location. Okay. So first off, I want to talk about the vertical shift. The vertical shift. This results when any value is added to the function. Look up above. So we just did parabolas of y equals ax squared. Notice now we're tacking on plus k, a value. Now I'm going to start out with something linear because the principle applies. So y equals 2x. Here's the xy chart of that, and here's the graph of it. Okay? Pretty standard. We've done that a ton. But look to the right. Now we're going to take that exact same function and add 2 to it. We've increased the function by 2. Now, I'm not even going to do an xy chart on this. Come over to the graph. Look at this point right here. The output in the left-hand equation of an x0 gives you a y of 0. But now this function is 2 higher. Therefore, my 0x point, the y value is going to be 2 higher. Go to the next point to the right, 1, 2. My new y value is going to be 2 higher. Go to the next point to the right and go 2 higher. And go to the next point to the right and go 2 higher. Because that positive 2 adds 2 to the output every single time. And we now have a line that is 2 higher. Now again, doesn't quite look it, but again, it's 2 higher. No matter what 2 points you pick, even ones that aren't right on the axis, the point above is 2 higher. Because this made it go 2 higher. Right? Made it go 2 higher. So let's go ahead and deal with this aspect with a parabola. Remember, the k value translates the function vertically up or down. Okay, so look at our parabola here. So now here's the base parabola on the left, y equals 1/2 x squared, and I graphed it for you. And here it is in blue, y equals 1/2 x squared. Now we're going to take and tack on a -3. Now I can go through with an xy chart, and I can come up with all these values with an xy chart. I could do that. But I don't need to do that. I don't need to do that. I'm just going to come to the parabola and I'm going to go down 3 from every point. All right, from the vertex, go down 3. From this point to the right, go down 3. See, I'm right here. I went down 3. Go all the way to the right. Go up here. Go down 3. Go to the left of the vertex. This point, go down 3. Go to that last point to the left. Go down 3. Draw your parabola. This is the exact same width. Just translate it 3 down because of the -3. Every output is decreased by 3. Okay, so now we have a new pattern, and it's right here. So this is now the next situation. Y equals ax squared plus k. There's no bx term, there's a k. The coordinates of the vertex will always be 0, k. Now look, this is something you have to remember. Some of you guys, I teach you this stuff and you understand it while I'm explaining it, but you forget it. You got to review. You got to review. You got to review. Okay, so look at our example. Y equals 3x squared plus 7. What's the coordinates of the vertex? Okay, there's no bx term, so that's a 0. And what's the value of k? 7, 0, 7. Second example, again, there's no bx term, so the x coordinate of the vertex is 0. What's the k value? -5. Now in the third example here, hey, we're not in the right form yet, correct? We got to move this 6 to the other, this -6 to the other side, add a 6 to both sides. So plus 8. Again, I know I'm going fast. That's why with video you can go back. So what are the coordinates of the vertex? 0, 8. 0, 8. All right. I got teacher meeting coming up, and it looks like I'm going to miss it because I got to finish this lesson. All right, number 7. State if it's a max or min, if it opens up or down, the vertex coordinates, the vertical shift, the line of symmetry, and the relative width. Oh my. Lions and tigers and bears. Oh my, that's a lot. Okay, not a problem. Not a problem. First off, let's figure out whether it's a max or a min. So we're back to the A value. The A value is positive. Therefore, it is a min. And mins open which way? Up. Okay, good. Let's now do the vertex. Is there a bx value? No. Is there a k value? Yes. What is it? -4. Vertex, -4. What's the vertical shift? Down 4, right? Because of the -4. What's the line of symmetry? The x equals the x coordinate of the vertex. That gives you a vertical line through x equals 0. And is this thing relatively wide, flat? or narrow? Steep. Well, 3/5 is less than 1, so this thing is relatively wide. And again, your book would say flatter. Okay? Let's do another one. So is this a max or a min? Max or a min? Take a look at it. Hopefully you say a min because it's a negative A. So that's a min. I mean, max, brother. Right? Negative A is a max. How do maxes open? They open down. Down. What are the coordinates of this max point? X coordinate is 0. Y coordinate is 6, right? The K is 6. How is this translated? Nothing left or right, but up 6. What is the line of symmetry? X equals 0. It's a vertical line through X equals 0. Is this thing relatively wide or relatively narrow? Well, again, the absolute value of -1 is 1, and by our definition, that is narrow. But again, your book would call that steeper, okay? Narrow or steeper. You're going to have to be able to do that. Again, this is the kind of thing you'll do constantly in homework, quizzes, and tests. You got to be able to read quadratic functions. Okay, almost done. Couple quick examples, and I know this has been a long video. Forgive me for that. So much information here. You got to come back and watch the video again. Yeah, that's my advice. You got the notes down. Come back later without taking notes and just watch it. And watch it again one more time and try to simulate all of what I'm saying. All right, number 8, state if it's a max or min, the vertical coordinates, line of symmetry, and then graph it. See, I'm setting you up in how to graph. If you were just told graph y equals 1/3 x squared minus 1, what you need to think is, okay, first off, is this a max or a min? Hopefully you say it's a min. Now you want to say the coordinates of the vertex, and hopefully you say 0, -1. Okay? And then the line of symmetry is x equals 0. And then graph it. And notice in blue up here, plot the vertex first, then the line of symmetry. So I'm going to go to 0, -1 right here, and I've got my vertex. Now, which way does this open, up or down? It's a min, it opens up, so my line of symmetry is up this way. That's how you start. You got to start. You got to do this first. That's your starting point. And when they're translated left and right as well as up and down, it's really important, really key. Okay, from here, it's an XY chart. It's an XY chart. Now, I've already used x equals 0. It's right there. I could use 1. I could use 2. But look, I have a fraction. If I use factors of the denominator, factors of 3, I'll avoid fractions. So my first point's going to be 3. Hey, if you don't do that, it'll still work. It's just a little trickier. All right, write the function 1/3 where the x is, leave a parentheses. So I have 1/3 x squared minus 1, and we're going to put a 3 in for the x, right? All right, so follow along. 3 squared is 9. 9 times 1/3 is 3. 3 minus 1 is a 2. I have the point 3, 2. 3 to the right, 2 up. 3 to the right and 2 up. Now watch. Look right here. I have a point 3 to the right of the line of symmetry. I will put a point 3 to the left of the line of symmetry. See, I get 2 for 1 sale, right? Buy one, get one free. Woo, awesome. All right, that's good. Saves you time. Now again, because my denominator is 3, I'm going to go another 3. So I'm at 3 already. So I'm going to go to 6. Is that the only way to do it? No. Probably the best way though. Okay. So I'm going to use 6 for my x. Same template. 1/3 times quantity x squared minus 1. Put a 6 in. All right. Again, pause where you need to. 6 squared is 36. 36 divided by 3 is 12. 12 minus 1 is 11. Did I do that right? I think I did that right. Is 11. So I'm at 611. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, look at that. Perfect. Whoever made this was awesome. All right, 11. And notice I am 6 to the right. I'm going to go 6 left. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5. Oops, right here. 6 to the left. Okay. And now I'm ready to draw my curve. I'm going to draw mine in blue. Here's my parabola. Going off that way. Going off that way. Awesome. Hey, what's the domain? All real numbers. Again, you could write it as an interval. What's the range? Y greater than or equal to -1. What if you wrote it as an interval? Bracket, -1, comma, infinity, parentheses. All right? Pretty cool. All right, one more. All right, one more. One more. Last one. Last one. Because I've taken so long, I won't go back and review, but you could. A lot to assimilate. I know, a lot to assimilate. Okay. Remember, how do you start any graph? First determine, is it a max or a min? What is this? Max, because of the -3. Okay, what's the max point, the vertex coordinates? 0, 5. Okay, what's the line of symmetry? X equals 0. Plot this first. So go to 0, 5, 1, 2, 3, 4, 5. Okay, way up there. You gotta do this first. And again, when we start moving them left and right, it becomes even more important. You gotta plot that vertex first. Let me plot my line of symmetry. This one opens down, so my line of symmetry goes like that. Okay, don't have a fraction, so I'm just gonna use 1 next. By the way, I'm knowing that this is relatively steep, right? I know that already because of the 3 value. So now, again, where the x is, I'm going to put in 1. 1 squared is 1. 1 times -3 is -3. -3 plus 5 is a 2. I'm at the point 1, 2. 1 to the right and 2 up. Because I have a point 1 to the right, I know I have a point 1 to the left. 2 for 1 sale. See how steep I am already? Okay, let's do the point 2. -3. Now we're going to put a 2 in. 2 squared is 4. 4 times -3 is a -12. -12 and a +5 is a -7. Wow, that got down there fast, didn't it? 2 to the right and 7 down. 1, 2, 3, 4, 5, 6, 7. I went 2 to the right. I'll go 2 to the left. Draw your parabola. And there it is. Okay. Domain, all real numbers. Range, y less than or equal to 5. How would you say that in an interval? Parentheses, -infinity. Lowest always the highest, comma 5 bracket. Comma 5 bracket. All right. I got to review real quick. Okay. Don't forget how to classify. The degree tells you whether it's linear, quadratic, or polynomial. The number of different variables, 1 is equation, 2 is function. That's the key to that chart. Parabolas are a U-shape. They have a line of symmetry. Hey, notice this one is moved left, or I'm sorry, to the right 3 and down 1. We'll talk about that later. The key, though, was I started with my vertex, didn't I? You got to start with your vertex. Okay, they're symmetrical. They got a line of symmetry. The first easy form, y equals ax squared. Okay, there's no bx, no c. With that, you know the vertex is always 0, 0. You know the line of symmetry is always x equals 0. Then we learn positive a's open up. They're mins. Negative A's open down. They are maxes, right? Positive A's open up, negative A's open down. Then we learn the relative width. Look at the absolute value of A. If the absolute value is less than 1, we'll call it relatively wide or flatter. If the absolute value is greater than 1, we'll call it relatively narrow or steeper. I showed you there the comparisons among the parabolas. Then we had a vertical translation, a vertical shift. We're shifting the function up or down by the number that's either added or quote unquote subtracted from the function. So where you would have been done with the values, you're either adding more to the final output or decreasing the final output. That's going to shift the function up or down. Again, what are the coordinates now? The vertex 0k, 0 and the value of the k. We did some of those, and then we went through. I showed you how to read them, and I showed you how to graph it. All right, I know that's a long one. I apologize, but important stuff. Review this video again. It's going to set up the whole chapter. Have a great night.